Hello, this is Mr. Agbamu Idanogrene. This is an applet I also want to demonstrate for you here. Though this applet, I'm not the one that designed it like this. I actually got it from the GeoGebra Classic software website. And I've showed you in one of my videos how you can get applet from the geogebra.org website. But I just did a little bit of modification in this, so this is not totally exactly the way it came from the GeoGebra website. So, but it's also a good one you can use in your classroom. So to download this applet, just go to the description of the video. You will see the link there. Just click on the link, use it anytime in your class. But what is this applet actually talking about? I'm trying to see some definition of some types of numbers we have in our classroom. That is why I called it number system. And sometimes our children do ask a question like, sir, what do you mean by natural numbers, whole numbers, integers, rational numbers? Understand? Sometimes irrational numbers, you see, because sometimes in the classroom you may tell them that, like when we are doing topics like binary operations, sets, all these are topics. Sometimes they will say if set A are integers, student will say, sir, what do you mean by integers? Sometimes you can say if the binary operation is defined on the set of real numbers, students usually ask, sir, what do you mean by real numbers? Or a set of irrational numbers, all those kind of stuff, or a set of natural numbers. So, and all these minor definitions are very important in mathematics. So this applet is just to give you the basic meaning of all these terms in maths, then few examples, then you can go on and study more from your textbook. But for quick study in your classroom, you can just project it to your student, let them just see it fast, then lesson continues. It's a quick way to show your children in the classroom in case of any doubt or maybe any confusion in the meaning of any of the numbers. So all I just need to do here is just to come here. So the first number I have here is natural number. So what are natural numbers? We say they are the ones we learn to count with from a young age. You know, as a young student, when you start from the early years, nursery school, primary school, we always start with counting of numbers from 1, 2, 3, just like that. So those are the natural numbers. So they are the normal counting numbers. So we say the name of counting number. So they are the counting number. Natural numbers are counting numbers. You can see there's no zero here. We just start from 1. We don't start with 0. Just start from 1, 2, 3, 4, just like that, and so on. So that is that. So this is the meaning of natural numbers. So take note of this. Then the next one is whole number. So what are whole numbers? So whole number consists of all natural numbers. Remember, whole numbers don't have any decimal attached to them. They are single number. So that is why they are natural numbers, but with the addition of 0. If you check the previous one we checked, natural numbers are just number 1, 2, 3 without 0. Then they are the counting numbers. Then whole numbers are also count natural numbers, but they start with 0. You must put the 0 from the beginning. So these are whole number. So 0 is very important number which comes before the counters. Very important. And you know what 0 means? It means nothing. A number that means nothing. But more importantly, the 0 permits the use of place value system, which has made arithmetic easier. You know, when we are talking of place value, 0 is very important in that. So that is another aspect. So this is what whole numbers means. So take note of that. There are natural numbers that begins with 0. You must put 0 there as one of them. Then the next one is integers. What are integers? So integers are all of the whole numbers with the addition of the opposite value of the natural numbers. Just like natural numbers are the normal counting numbers from 1, 2, 3, 4, 5, just like that. Then we now say the whole numbers are the also natural number but with the addition of 0. But integers now are also natural numbers, but this time around you must include the negative numbers, you see. So when negative whole numbers is included with 0 together with natural numbers, so we call them integers. So integers are whole numbers consisting of negative numbers, 0 and positive numbers. So this is what we usually use in our number line. So when you check the number line system, you see the 0, then positive whole numbers, negative whole numbers. So that is what I mean by whole numbers with the addition of the opposite value. The opposite value is the negative value here. We say these are called the negative numbers. That is the negative values now. They are called the negative numbers. Why do we call the negative number? This is due to the negative sign used to display the difference from the counting number. Now the counting numbers are said to be positive numbers. So take note, counting numbers are natural numbers, don't forget that. So they are only positive. So counting numbers are positive numbers. There is no negative number attached to them. So any counting number added to its opposite is always 0. So this is just a simple observation. So when you add a positive number to its negative, it must always end up 0. Just like 5 plus minus 5, it will always end up as 0. Minus 6 plus 6 will always end up as 0. 21 plus minus 21 will always end up as 0. So very, very important. Just like this. So this is 1, negative 1. So negative 1 plus positive 1 will give you 0. Negative 2 plus positive 1 and negative 2 will give you 0, just like that, and so on. So these are the meaning of integers. Please take note in case you see a question in your set or binary operation, any of those topics in math, and the set consists of integers. So you should know what they are talking about. They are talking of both negative or positive numbers in addition with 0. So the next definition I have here is rational numbers. So these are just numbers in the ratio form. So they are also called fractions. These are fractions. But one thing you must take note about rational numbers is this: rational numbers all may be terminating decimal numbers, or may be a repeating decimal number, which are also called recurring decimal numbers. So take note of that. That's why in the statement I have here, rational numbers are numbers which can be written as a ratio of one integer to one counting number. When I say counting number, remember 0 will not be there. That means the denominator will not be 0. So it's a ratio of a number with any counting numbers without 0. Because counting numbers are natural numbers, they don't have 0 attached to them. So if you have 2 over 1 is a rational number, just like that. Then if the number has a terminating decimal, take note, it's a rational number. Then if it's a repeating or recurring decimal numbers, take note, they are rational numbers. So if you keep on going, let's see what fractions actually mean. So fractions are ratio of an integer to a counting number. So you can see 5 over 6 is a fraction, or you can say 5 ratio 6. So all these are rational numbers. Then minus 8 ratio 25, which is the same thing as minus 8 divided by 25. All these are rational numbers. And if you try to express them in decimal form, you can see 5 ratio 6, which is 5 over 6, is 0.868333. So this is what I mean by repeating decimals. So all repeating decimal numbers, like this case now, 0.83333333, just like this. That's why you see this symbol on top of it. It keeps going forever like this. So it's a rational number. Very, very important. Take note of this. Then 0.32. So when you convert 8 over 25, that is negative 8 over 25, it's a terminating decimal. That's why I said all terminating decimals are rational numbers. So 8 over 25 will end up at 0.32. So it terminates at this point. So it's a rational number. Take note of this. Rational numbers are numbers written in ratio form or in fractional form. That's what I mean by these are called fractions. So fractions are actually rational numbers. Even the ones with recurring decimals, like this form, they are rational numbers. The one with terminating decimals are rational numbers. Take note of that. Then what does repeating decimal means? So repeating and terminating decimal numbers are decimal representation of ratios or fractions. So I'm just trying to, this statement here just to tell you the meaning of repeating decimal like these examples, or terminating decimal like this example. So you can see them. So 5 ratio 6 is represented by a repeating decimal. So that's what I mean by this. So 5 ratio 6, which is 5 divided by 6, it will keep going forever, 3, 3, 3, 3, 3, forever like this. Then in this case, we say 3 repeat forever and ever. You can see the statement here. Then 8 minus 8 over 25. This is a terminating decimal, so it's represented by a decimal which terminates. So this 8 over 25 terminate at 2, that is 0.32. So it's also a rational number. So all these are just a way I use to define rational numbers. Take note of this. Okay, now if you move on, irrational numbers. So irrational numbers are numbers whose decimal never terminate or have any pattern in the decimal. So without wasting time, you can see the examples. But before I go through the example, you see what I have here, all non-terminating. So there are some decimals that don't terminate. For example, pi. Pi keeps going like this forever, and it does not have any pattern in it. You can see it keeps changing 3.14159265. So it just keeps scattering and keep going like that. Look at square root of 2, 1.414213. See, it keeps going, no repetition. See, no terminating. It will keep going like this forever. So all these are examples of irrational numbers. So they are non-terminating decimals and they are non-recurring. So they don't repeat themselves continuously like 1, 1, 1, 1, 1, 2, 2, 2, 2, 2 like that, like what happened in rational numbers. See, this keep repeating. So when it keeps repeating, it's a rational number. So if it does not repeat, it just keep going and keeps changing. That means have any pattern. It does not have a particular pattern. See, that's what I mean by this. So these are irrational numbers. And remember, in mathematics, when we talk of solved, that is why we use them in problems in solved, especially these roots. So most of the root of numbers now, which are not perfect square, we usually refer to them as irrational numbers, like square root 2. See, the square root 4 is not an irrational number because 4 is a perfect square. Square root 4 is 2, so it's a rational number. So we are talking of square root of numbers that are not perfect square, like square root 2, you can see it, square root 3, square root 5, square root 6, square root 7, just like that. They are irrational numbers. See, there are indefinite many irrational numbers. So there are so many irrational numbers. So this is one of the easy way you can remember the meaning of irrational numbers. They keep going without stopping. The decimal keep changing without having any particular pattern. So they are non-terminating and they are non-recurring decimal. So the last meaning I have here is real numbers. So real numbers are actually set of rational and irrational numbers. So when you combine the rational numbers and irrational numbers together, you are going to have what we refer to as real numbers. And take note, rational numbers are actually whole numbers. See, because all whole numbers are ratio of themselves to 1. So a whole number 4 is the same thing as 4 over 1, which is a fraction, which is a ratio, and it's also a rational number. So actually all whole numbers are rational numbers. See, and they are also real numbers because real numbers consist of rational numbers and irrational numbers. So that is why in mathematics, when you see problem that says the set of real numbers, just pick any number, because even if you pick a rational number, it's a real number. Even if you pick an irrational number, it's a real number. So most examples that are in math, I usually talk about the numbers are set of real numbers. So any number you actually pick there will be correct. You can see the terminating decimals are rational numbers, recurring decimals are rational numbers, whole numbers are rational numbers, fractions are rational numbers, and they are all examples of real numbers. You can see what we are talking about. Then irrational numbers, we see square root of a non-perfect square, like square root 2, square root 3, square root 5. They are all irrational numbers, and they are also real numbers. Then a decimal which does not repeat or terminate. So like square root, like pi, for example, 3.142. She keep going. It does not repeat itself in a particular way, like 33333, and it does not terminate. So that is why 22 over 7, we usually use it to represent pi, because it just keep going like that. It's a non-repeating decimal or non-recurring decimal, and it's also a non-terminating decimal. So take note of that. So actually most numbers are usually real numbers, because you can see the classification. Rational numbers are whole numbers. They took the examples of almost all the other types of numbers, apart from irrational numbers that are actually square root of non-perfect square and numbers which does not repeat decimal or which does not terminate. So this is all I have in this video, the meaning of these types of numbers in mathematics. You can use it once in a while if your student asks you some questions and you are rushing and you don't have time to explain in details. You can just display this to them, or you can have it with you. And this is a simple applet. And to download this applet, as I said before, just go to the description of this video, click on the link there. You can have it, use it anytime in your class, and you enjoy it with your student. So thank you for watching. Hope you enjoy this video. You have a nice day.